Hey chemistry students, this is Mrs. Miller, and today we're going to be talking about metrology, or the study of measurement. It is not meteorology. We are not looking at weather patterns, people. It is the study of measurement. So a while ago in class, you probably would have had your teachers asking you a bunch of questions like, how many pints are in a gallon, or how many sheets of paper are in a ream, or blah, 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 blah. All sorts of different things talking about the differences between the metric system and using the imperial system of measurement, or the English system is what we tend to call it. So we know that the United States, along with 2 other countries, uses the imperial system of measurement. Again, sometimes this is referred to as the English method. So we know that we use things like foot, inch, yard, things like that. We know how these things were created, like the foot. It was first believed that like the length of your foot was a foot. Yeah, it's not the same for every person. We know that we have different shoe sizes. It's a terrible method of measuring. It's also really, really difficult to convert, unlike the metric system, which is the system that we always use in science. So no matter what country around the world you're looking at, they are all using the metric system in science, mainly because it's much, much simpler to convert. With the metric system, we tend to call this the International Unit System of Units. I find that to be slightly redundant and really, really long, but it's the modern form of the metric system that is most widely used when we talk about measurement. So again, no matter what country we are talking about, every single scientist around the world is going to be using the metric system. That's why we measure things in milliliters, in centimeters, and things like that that deal with the metric system, so that all of these measurements can be converted from one country to the next. Imagine how bad it would be if NASA was using the English system, but China was using a different system, like the metric system, and we tried to make some sort of spacecraft that worked together when each one of us provided parts. That wouldn't be great because we'd have to sit there and convert units. So instead, scientists all use the same. We abbreviate this giant name as the SI system. And what we do with this is we use a series of prefixes to easily convert between units. You guys are probably familiar with these units like kilo, hecto, deca, deci, centi, and milli, like a millimeter or a kilometer. So the larger units are kilo, hecta, and deca. The smaller units are deci, centi, milli, and then the base units are in the middle. So what we use as base units are things like gram, meter, liter. So you've heard of things like a milliliter or a kiloliter. We've talked about things like kilograms or milligrams. So those are just some differences. In science, we tend to have 5 basic measurements that we are going to use with our base units. 3 of them are really, really common. The other ones, not so much in chemistry, but we do use them. So we have our first one being mass. We know that the base unit is going to be a gram. So the next one that we look at is volume. So anytime that we want to measure how much liquid of something, we are going to use the base unit of liter. So if we want to know how much mass it has, or we're dealing more with weights, that's where we use grams. We are going to use liters when we talk about amounts of liquids. Length, of course, we are going to be measuring with the base unit of meter. Time, the base unit is going to be second. And temperature, the base unit is going to be Celsius. We don't use the F word in chemistry. We always use Celsius. Fahrenheit is not a good example of a temperature scale that we use in science. So those are our base units that we're going to use. And from there, we can use all those other prefixes to help us better understand the different units. So here we have our common prefix names. So it doesn't matter which base unit we're talking about, they're always going to mean the same things. So the multiplying factor is what we're going to be looking at today. So kilo, for example, has the largest multiplying factor because it represents the largest unit. whereas milli is going to have the smallest multiplying factor because it's the smallest unit. So if you think about kilometer, like kilometer, right? So if you had to run a kilometer, that's a lot further than if you had to run a millimeter, right? You could run a millimeter in tiny amount of time. It might take you a little longer to get to the kilometer. Just like if you're like, hey, I want to drink a kiloliter of soda, that's quite a bit, versus a milliliter of soda is barely anything, okay? So we go from the largest down to the smallest, and what you're going to see here, kilo is the largest. We abbreviate that with a K. Hecto is then a little smaller. You can see that its multiplying factor is 100. So that's an H. Deca is a capital D, because if you notice, deca and deci would have the same abbreviation. We abbreviate deca with a capital D because it's larger, and deci with a lowercase d because it's smaller. Centi is a C, and then milli is a lowercase m. So those are going to be important as you try and figure out what these things mean. So if I said CG, that would be a centigram. Okay? So we are going to use these, and notice that they are always going up in factors of 10. So 10 times 10 is 100. So a decaliter is 100 times smaller than a hectoliter, which is 100 times smaller than a kilo. Okay? So they're going up by factors of 10 or going down by factors of 10. One method that I really like to use is something called the prefix stairs or the prefix system. So with the prefixes, we can arrange them as a set of stairs that allow us to convert easily between units. To convert, all we have to do is move our decimal place. Prefixes at the top are going to be larger, and prefixes at the bottom are going to be smaller. Remember, on this, we probably would want to have deca as the capital, just because we are able to show that deca is larger. So in the middle here, this is our base unit. So this might be meter, liter, gram, second, etc. Okay, so that's what we see on our base unit, and then we can apply those prefixes as necessary. One thing I want to teach you guys is how to use these stairs as a method for converting. So again, the first thing that I want to do is I want to switch this so it says deca with a capital D so it's easier to understand. So here's an example question of where I might use the stair method. So I have 156 meters and I want to convert that into kilometers or kilometers. Okay? So what I'm going to start is I'm going to say 156 meters. The first thing I want to look at is where's the decimal? If you don't see a decimal, the decimal place is at the end, okay? No decimal implied at the end. Okay, so that's why I'm going to place my decimal after the 6 in this case. Then what I'm going to do is I'm going to say we're starting here. We're starting on meter. Okay, so I'm starting right in the middle of the staircase. And what I want to do is I want to go all the way up to kilo. All right, so what I'm going to do is I need to jump up 1, 2, 3 moves. Okay. So I'm moving 3 up the stairs. So if you go up the stairs, what you're going to do is you're going to move decimal to the left, okay? And you're going to move it the same amount of stairs that you're moving up. So in this case, we went up 1, 2, 3 stairs. So I need to move my decimal place 3 to the left. So I'm going to go 1, 2, 3, new decimal place. So then my answer becomes 0.156, and now I put the K in front of the M to say kilometers. Okay, so figure out where you're starting, figure out where you're ending, how many stairs did you have to move, and what direction. Our next one, we want to know how many millimeters are in 1.2 meters. So I'm going to again start by writing down 1.2 meters. And that means we're going to start here. We're again starting in the middle of the stairway. So I want to go down to milli. So I'm starting here and I'm ending toward the bottom. So what I have to do now is I'm going down the stairs, 1, 2, 3. So going downstairs, down 3 stairs is what I should have said. When you go downstairs, we move decimal right. And that makes sense because as we're going down like this, we're also going off to the right side. So up equals left, down equals right. So now what we're going to do is we're going to move our decimal 3 spaces to the right. So we go 1, 2, 3. So notice now we have these 2 empty depressions. So what happens is we're going to fill those depressions with zeros. So we're going to say 1200 millimeters. Notice I didn't put a decimal place on there. The reason why I didn't put the decimal place on there is for sig figs. So this value had 2 sig figs. This value has to have 2 sig figs. So if you put a decimal on there, now you have 4. So that's why I use the stair method to get that with no decimal place. So my answer down here, you may or may not need a decimal. If I have 1 meter, how many millimeters is that? Again, we went down the stairs, 1, 2, 3. So that would be 1,000 millimeters, no decimal place, because I went down the stairs to the right. All right, so I have 3 practice problems that I would like you guys to try. Go ahead and pause the video and we'll come back. So my first one I'm going to try is we're going to convert centimeters to millimeters. My second one, we're going to convert milligrams to centigrams. And my third one, we're going to convert milliliters to kiloliters. So I'm going to start with my green. So I'm going to put my starting point. I'm starting at centimeters, and I want to go to millimeters, which is down here. So I'm just going to go down the stairs once. Remember, up equals left, down equals right. So what I'm going to do here is, where is my decimal place? Well, if it's not listed there, it's implied at the end. And then what I want to do, because I'm going down the stairs, I need to go right, and I went down 1 stair, so I'm going to have 1 depression. So I need to fill that, and I say, this is my answer. So 15,000 millimeters is equal to 1,500 centimeters. My next one, I'm going to start on milligrams, and I'm going to go up to centigrams. So this time, I'm going up the stairs 1, so I need to move my decimal place 1 to the left. So where's my decimal place? Well, if it's not listed, it's implied at the end. And I need to go 1 to the left. So my answer is 125 centigrams. Notice I don't write it like this because the sig figs would be wrong. And my last one is I'm going to convert from milliliters up to kiloliters, okay? So I'm going to move 1, 2, 3, 4, 5, 6. So I moved 6 to the left. So I'm going to move 6. Oops, I went 6 up the stairs. So I'm going to move 6 to the left with my decimal place. Okay, so I'm going to go 1, 2, 3, 4, 5, 6. And what goes in each of these little depressions? Of course, those are zeros. So I'm going to say 0.1, 2, 3, 4, 5. Kiloliters. All right, so that's how you use the stair method. Identify your starting place and your ending place. Figure out if you're going up or down the stairs, and then how many, and then you'll know exactly where to move that decimal place. So here we have those same exact answers. I just do not have the practice or the stairs that go along with that. But as you can see, it was just moving all we did was move our decimal places. And remember to keep the proper amount of sig figs. If you guys have any questions, let us know. Otherwise, have a great day.